Hello, my name is Chris Bowie, and my capstone 2 project was on forecasting EMS call rates in San Francisco. So the problem I was trying to solve was how can EMS vehicles be allocated throughout the city on a daily basis to maximize the efficiency of their distribution and reduce the response times to medical incidents. And the use case was by predicting the EMS call rates by neighborhood on a daily basis. You could use those values to decide how many vehicles should exist in what neighborhood throughout varying points in the day. The data I had was 5.32 million EMS call rows, and after removing duplicates, I ended up with 2.6 million EMS calls spread over a 20-year time span. And I aggregated that data into 3-hour time periods throughout the day for a total count in each data period, and ended up doing my predictions on a week in August in 2018. So splitting my data up by neighborhood, I looked at the 20-year trend of the data, and this is the yearly trend. And you can see each neighborhood has a similar proportional increase over the last 20 years. The monthly seasonality is also similar, peaking in the holidays and hitting a minimum in February. Weekly seasonality is also similar across the neighborhoods, getting higher on the weekends and lowest on Sunday generally. And the daily seasonality, which is the most important since I'm doing daily predictions, shows that across each neighborhood, it peaks in the mid-afternoon and it hits its minimum in the early morning or late night. And so the two models I compared were an ARIMA model and a profit model. My ARIMA model had a very high runtime, so I decided to just use 3 weeks of data to predict a 4th week. I ran a grid search to optimize hyperparameters and ended up with the following, where this graph is split into 2 weeks. The first week is data the model was trained on, and the second week shown there is the data the model was tested against. And then using Facebook profit model, it had a very fast runtime, so I trained it on the full 2 years of data leading up to that target week. And this is the results of that model with on the same scale. So that first week, first half of the graph is the last week the model was trained on, and the second half of the graph is the predicted week. You can see both of them capture the daily seasonality pretty well. And I compared the models against a baseline, which was just using the previous week to predict the next week. You can see both models had a significant improvement on that baseline, but the profit model performed just slightly better, so I decided to continue forward with that. And I looked at the daily 3-hour increments over the 2-week period at 3 different neighborhoods. It just shows, it captures a similar seasonality, but with some variation across them. And then similarly aggregated by day in each neighborhood. This is showing the prediction out for that week in that year based on the 2 years of trained data. And for next steps, I would use an LSTM model because I could capture some other features like the distribution of call types in each data period. I'd also try to add in holidays so I could capture some of the significant anomalies around holidays where there's going to be peaks in EMS call rates. I'd also try to optimize parameters and test it on more weeks of data. And some exciting further use case is essentially using the model to do more inferential statistics. I was able to see some specific peaks in the residuals and find some events like a heat wave and a power outage that led to disproportionately high unplanned peaks in the data, which if I had it on holidays, that would take care of the holiday one. So I could still find other residuals that would help create essentially more features that I could then include in the model to predict events that would cause spikes as we see here. Thank you.